Well, all right. Well, we're marching down this road, which is sometimes tedious, of proofs, and we're looking at algebraic proofs at the moment. And what we're going to deal with here corresponds to example 1, of chapter section 2-6, which starts at the bottom of page 136, goes over to the top of page 137. And we've got 3 statements that we're going to justify by using algebraic proofs. And the first couple are fairly easy, and then we got a few steps we're going to have to deal with. So let's look at number 1. It says if 4 plus negative 5 equals negative 1, then x plus 4 plus negative 5 equals x plus 1. So this is our given. If 4 plus negative 5 equals negative 1, and this is what we're being asked to prove, that if that's true, then x plus 4 plus negative 5 equals x plus 1. So what's the difference between these two statements? And we can see here that we added x to both sides of the equation, and in doing so, we used the addition property. And that was pretty simple. Let's take a look at the next one. Here we've got if f equals y, then y equals, if 5 equals y, then y equals 5. If 5 equals y, then y equals 5. Well, here's what we're given. This is the if. These are conditional statements, you may remember. And we're asked to prove here what property would prove then that y equals 5 when 5 equals y. Got any ideas? Well, it is the symmetric property. All right, well, those aren't too bad. Now we'll do one where we got a few steps involved. So here we got prove that if 2x minus 13 equals negative 5, then x equals 4, and it then says write a justification for each step. So the 2x minus 13 equals negative 5. This is our given. And we're asked then to prove that in that case, x equals 4. So this is what we're setting out to prove. All right, so we're going to try to use this in a 2-column proof. Hopefully I can write this where it's legible. So we start off with 2x minus 13 equals negative 5, and that reason is our given. Okay, and then let's see, 2x minus 13 plus 13 equals negative 5 plus 13. Well, you might recognize that that is the addition property. And let's see then, that leaves us with 2x equals 8. And what we did there is we did substitution. First we took the addition property and then we solved that or substituted that. And then we end up with x equals 4, which is the division property. So what we're doing is we're taking each step in this case as we're solving an algebraic equation to prove what the answer is, and we are systematically defining each step that we're taking. So that gives you an example of justifying each step when solving an equation. Don't you just love it?